What if your classroom seating chart could dynamically optimize itself to maximize engagement without moving a single desk? Traditional fixed-grid layouts create invisible participation gaps. Back rows suffer from fatigue, while front rows dominate. Current assignment methods rely on teacher intuition or manual CAD tweaks, slow, subjective, and rarely globally optimal. Enter SETEASY, a multimodal AI framework that fuses physiological sensing, computer vision, and constraint-based optimization. Here's the technical stack. Each student wears an Empatica E4 wristband streaming electrodermal activity, blood volume pulse for heart rate variability, and 3-axis acceleration at up to 64 Hz. Simultaneously, a 4K overhead camera runs real-time head tracking via the SORT multi-object tracker, classifying 5 classroom behaviors per second. Environmental sensors log CO2, temperature, and noise. This multimodal stream feeds into VGauge, a LightGBM regression model trained on a revised engagement questionnaire. By fusing physiological arousal, behavioral synchrony calculated via dynamic time warping, and environmental load, VGauge predicts cognitive, affective, and behavioral engagement. The result? A stable RMSE drop from 0.75 down to 0.53. Those predictions build a student seat utility matrix. Every 2 weeks, the system maps historical engagement forecasts against spatial coordinates calibrated via ARUCO fiducial markers. Then Google's OR tool's CPSAT solver runs integer linear programming. It maximizes total utility while hard constraining variables like visual access, social dynamics, and accessibility. The output is a mathematically optimal seating chart, updated weekly. In a 4-week deployment across 331 sessions, the system eliminated back row low activity patterns entirely. Mean classroom engagement jumped from 0.3 to 0.7. Over 2/3 of seats hit high engagement thresholds. SETSY proves that even in rigid fixed layout classrooms, computational design can reshape spatial dynamics. By closing the loop between multimodal sensing and constraint-based optimization, we're not just assigning seats, we're engineering equitable, data-driven learning environments.